Okay, so we're picking up on Geometry Unit 6 and 7 review. We're moving on, we're on Part 2, moving on with question number 9. In question number 9, they tell us that Susan has a circular swimming pool that has an area of 314 square feet. So, she has a swimming pool, and all the space inside of it is equal to 314 feet squared, right? That's the area of the pool. And they want me to find what is the diameter of the pool. Well, in order to find the diameter, it's probably a good idea to find out the radius. Well, when you think about it, they kind of gave you the answer already to the formula of an area of a pool. What's the formula for the area of a pool? Well, there it is. The area is equal to pi r squared. And they give you the answer to it. They told you that it's equal to 314. So we can say that 314 is equal to pi r squared. They gave you the answer. You know that 314 is equal to pi times r squared. You also know what pi is. You know that pi is equal to 3.14. So 314 is equal to pi times the radius squared. And you're trying to solve for the radius. Well, these two are being multiplied together, so all that's left to do is just to divide both sides by pi, by 3.14. I would divide both sides by 3.14. 314 divided by pi is 100. And this divided by itself is 1, so I got 100 is equal to r squared. But remember, I'm looking for the radius. So I don't want r squared, I just want r. So I take the square root of 100 and the square root of r squared. The square root of 100 is 10. The square root of r squared is r. So r is equal to 10, so I got the radius. So the answer is A, right? Wrong. The radius is 10, but what's the question asking you for? Asking you for the diameter. Don't fall into the trap. Answer the question. So if my radius is 10, then my diameter is equal to 20. Let's move on to question number 10. Question number 10, I have circle A. They tell me that angle DAB, which is a central angle, is 135 degrees. Then that means that the arc that it makes, arc DB, is also 135 degrees. But the question is asking, what is the measure of angle DCB? DCB. If you notice, DCB is an inscribed angle because its vertex is on the circumference. And angle DCB is intercepting this arc here, or it's touching arc DB, which is 135 degrees. Well, if you remember, central angles are congruent to the arcs that they make, and the arcs are congruent to central angles. But inscribed angles are half the size of the arcs that they make, or the arcs that they touch. So if this is 135 degrees, and this is an inscribed angle, well then it's going to be half of that. 135 divided by 2 is 67.5. So the measure of angle DCB is 67.5 degrees. Let's move on to number 11. Question number 11, they tell us that we have circle A and that DB is tangent to the circle. DB is a tangent line. They also tell you that the measure of angle BDA is 16 degrees, and they want to know what is the measure of angle CAB. What is the measure of this central angle here? Well, the trick to this question is you have to remember that what happens when a tangent line meets with the radius of a circle, right? What happens when a line is tangent to a circle and it meets with the radius? Well, they're perpendicular. They make 90 degrees. That's the trick to this question. You got to remember that. You got to remember that a tangent line is perpendicular to the radius, which is 90 degrees. You know that this angle is 16 degrees. And what you have here now is a triangle. How many degrees are inside of a triangle? If you remember 180, you guessed correctly. Well, a triangle has 180 degrees. Well, 90 plus 16 is 106. That means that in this triangle right here, I've used up 106 degrees. And I'm trying to find this missing angle here. Well, 180 minus the 106 gives me 74. So this angle here is going to be 74 degrees. And together, all three angles equal to 180 degrees. So the measure of angle CAB is 74. And you notice that was not a multiple choice question. Let's move on to question number 12. Question number 12, you have a circle inscribed inside of a polygon, and they want to know what is the perimeter of the polygon, right? The black colors the black shading might have thrown you off, but if what you notice is you have a circle, and you have an exterior point, and you have two tangent lines, which are coming from that same exterior point. And if you remember, we said that tangent lines to a circle that come from an exterior point are congruent. So if this is 8, this is also going to be 8. Now, that also happens over here. Again, I have my circle. I have tangent lines coming from an external point. So if this is 3, this is also 3. I also have it here, where I have an external point and two tangent lines to my circle. So if this is 4, if this is 4, this is also 4. And finally, the same thing happens here. I have an external point, two tangent lines coming to the circle. If this is 1, this is 1. So now I have all of the parts, and all I have to do is add all of these together. 8 plus 3 plus 3 plus 4 plus 4 plus 1 plus 1 plus 8. Add them all together, and I get 32 centimeters. So the perimeter of this polygon is 32 centimeters. Again, notice that was not a multiple choice question. Let's take a look at number 13. Number 13, they tell me that I'm drilling a hole. They tell me that this angle here is 110 degrees, right? They tell me that all of the other central angles are congruent to each other, right? It says the 4 central angles are congruent to each other, so that means that this angle, this angle, this angle, that all of these central angles here are also going to be congruent. Well, if I add up all of the angles inside of a circle, how many degrees should I have? 360. This angle right here has used up 110 of them. So 360 minus 110 leaves me with 250 degrees. Now, all of these angles are congruent, which means that I have to divvy up or divide this 250 degrees equally between these 4 angles. So 250 divided by 4 gives me 62.5. So the measure of each of these angles is 62.5 degrees. And again, you'll notice that was not a multiple choice question either. Let's move on to question number 14. Question number 14, they tell me that I have a parallelogram, A, B, C, D. Look at the order of the letters, A, B, C, D. They want to know what is the measure of angle BDC, which is this angle right here. Well, remember, guys, this is a parallelogram. That means that opposite sides are parallel. And if these sides are parallel, then what I have here, this diagonal, is acting as a transversal. And since these are parallel lines, and this is acting as a transversal, then these angles here are called alternating interior because they are inside the parallel lines and they are alternating. They are on different sides of the transversal. So they are alternating interior angles, and if you remember, we said that they are congruent. So if this is 25 degrees, this is also 25 degrees, and the answer for that is A. Question number 15 was asking if you knew something else about parallelograms, except they didn't give you a picture. So in this instance, you had to draw your own one. So I did that here. I did my best to draw it. They told me that I have parallelogram RSTU. So I drew my little parallelogram RSTU. My letters are going in order. They tell me that the diagonals intersect, okay. They tell me that RE is 10. Well, they told me that they intersect at point E, right? I know that. They told me that from R to E is 10. And they told me that from S to U is 16. They want to know what is from R to T. What's the whole length of R to T? Well, you got to remember, guys, that in a parallelogram, the diagonals bisect each other. So if SU is 16, well then RT is bisecting into what? 8 and 8. And since SU is bisecting RT, if this is 10, then this side here is also going to be 10, which means that the length of RT is 20, which is choice C. choice C. Let's move on to question number 16. Question number 16, they tell me the vertices of a parallelogram are A, B, C, and D, and 1, 8. So here's 1, 8. So this is letter A. 4, -2. This is letter B, and -2, -7. This is letter C, right? And they want to know, well, what are going to be the coordinates of letter D? Well, remember, guys, a parallelogram, you know, opposite sides are parallel, right? So this side here is going to be parallel to some side there. This side here is going to be parallel to some side there. How do I find that missing point? Well, think of it like this. You see these 2 points right here? Remember, opposite sides have the same slope. Remember we talked about that? Opposite sides are congruent, but they also have the same slope. So if I wanted to go from point B to C, how would I get there? Well, I would go down 1, 2, 3, 4, 5 spaces down, and then 1, 2, 3, 4, 5, 6 to the left. So I'm going down 5 and 6 to the left. Well, if I do the same thing from point A, I'll find the other point. Let's go 5 down. 1, 2, 3, 4, 5. And let's go 6 to the left. 1, 2, 3, 4, 5, and 6. And I'm sure you could have probably seen that from early on, right? So if I want to find that point, well, from here to here, it's down 5 and 6 to the left. Well, I can also say the same thing from here. Down 5 and 6 to the left. And I'm going to end up there. And what I have is my perfect parallelogram there. Because the slopes of the opposite sides are congruent. Remember that. Question number 17. Okay, they want to know which statement best explains. So they show me a trapezoid here. They tell me that AC is x plus 7. And they tell me that BD is 3x minus 3. And by the way, this is an isosceles trapezoid, which means that the sides are congruent, like an isosceles triangle. And they want to know why I can say that this diagonal here, x plus 7, is equal to this diagonal here, 3x minus 3. And the reason for that is very simple. The diagonals in an isosceles trapezoid are congruent. It's just a rule that you have to remember. The diagonals inside an isosceles trapezoid are congruent. They're equal to each other, kind of like the sides of an isosceles triangle. And finally, number 18. Number 18, we have here a parallelogram. Excuse me, not a parallel. We have a, it's a parallelogram. We have a rhombus, right? PQRS. And they tell me, they want me to prove that PR is perpendicular to SQ. They want me to prove that that makes 90 degrees. Then they give me some definitions of the rhombus. They tell me that which sides are congruent to each other. They tell me that QS bisects PR, where here's QS and it's bisecting PR. Okay, that's cool. I know that diagonals bisect each other in a rhombus. Then they want a definition of bisecting. Well, let's take a look here. First choice says PT is congruent to RT. Okay? Well, PT could only be congruent to RT if this segment is doing what to it? Bisecting it. If SQ is bisecting PR, then these two parts, then PT is congruent to TR. That's the definition of a bisector. Let's take a look at choice B just to be thorough. It says here that B says PT is equal to QT. PT is congruent to QT? Not at all. That would just tell me that I have an isosceles triangle here. That is not the definition of bisecting. Remember, when you bisect, you cut into